Good morning friends, and in this video we are going to discuss about a very powerful algebraical concept and it's called as polynomials. What are polynomials? So a polynomial of single variable x of degree n can be written as Px is an x to the power n plus an minus 1 x to the power n minus 1 plus dot dot dot, and then finally we can write a1x plus a naught. This is a polynomial where a1, a naught, an, all these are just constants, and if it is a polynomial of degree n, then an should not be 0, because if an is 0, then this term will become 0 and this will not be a polynomial of degree n, but it can be the polynomial of degree n minus 1. So now if I just suppose if I have only one term, Px is all my an is 0, an minus 1 is 0, till a1 everything is 0, I have just only a naught. Is it a polynomial? Yes, this is a polynomial of degree 0, or also called as constant polynomial. So the degree of this polynomial is 0. If I have Px, just I pick the last two, that is a1x plus a naught. This is a polynomial of degree 1. This is a polynomial of degree 1. If you take last three terms, then you get a2x square plus a1x plus a naught, and that is a polynomial of degree 2. And if you take one more, it becomes a cubic polynomial, a3x cube plus a2x square plus a1x plus a naught. This is a polynomial of degree 3. Now this is just an expression, so what you can say that this is polynomial is just one algebraical expressions involving the variables x, and that is called a polynomial of single variable x. You can also have the different variables, like you can have polynomials of the degree n with two variables x and y. Then you can have different coefficients, and each coefficients may involve x and y, but that we are not discussing right now. We are discussing only this basic polynomial. And now here you know how to find the value of the polynomial. So see, an minus 1, a1, a naught, all these are the constant value, and x is the only variable involved in these expressions. So if you want to find out the value of the polynomial, then you have to put the value of the variable, and then your expression will give you one numerical value. So suppose if I say that x is equal to 1, then I get p1, and then I get an plus an minus 1 plus dot 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 plus a0, like that. And this an minus 1 plus dot 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 plus n, if all of them are the real values, then this will be called the real valued polynomial. And if this an minus 1, a b naught, if any one of them is a complex variable, then that specific polynomial will become a complex polynomial. But we are not discussing complex polynomial, we are discussing only the polynomials which are real valued polynomials, which is like that. So now I just need to clear my screen, and then you can understand how to use them in our mathematical application. So for that, let me clear this. So let me assume a polynomial of degree 3. So suppose I have 2x cube plus 3x square plus 4x plus 7. This is a polynomial of degree 2 because degree 3, sorry, because the highest power on this x is 3. Now if I put the value of x as 1, so I get 2 plus 3 plus 4 plus 7, that is 7, 3, 10 and 6, 16. So this is the value of the polynomial when x is 1. If you have a value p0, then you get the value is 7, because all these terms where x is involved vanishes, and then you will be left only with this constant term, that is 7. So now if I take value of x as -1, then I get -2 plus 3 minus 4 plus 7. So this is -8 plus 10, this is 2. So these are called the values of the polynomial. Just assume that if there is any value of the x for which the value of the whole polynomial becomes 0, then that value of x is called as zeros of the polynomial. So now let me clear the screen, and next time I'll set another examples where I'll try to find the zeros of the. Now I take another example of the polynomial, and it is again cubic polynomial. So I take 5x cube plus 3x square plus 2x plus, I make this one as 1, and then here I write 6. This is better. So 5x cube plus x square plus 2x plus 6. So now suppose if I try to find out p0, then what do you get? 6. If I try to find out p1, what I get? Then 5 plus 1, I'll get 5 plus 1 plus 2 plus 6. That is 6 to 8 and 1, 9, 5, 14. If I try to find out p minus 1, then I'll get -5, because -1 power, actually you get like this. 5 minus 1 whole cube plus -1 square plus 2 times -1 plus 6. Now -1 to the power odd number is always minus. -1 to the power even number is positive 1. Again this is odd number, so this is -2 plus 6, and if you add them all you'll get 0. 6 plus 1, 7 positive and the 7 negative. So x equal to -1 makes the whole polynomial 0, is 0 of a polynomial. Okay, now how to add two polynomials? So when you are adding two polynomials, then you have to make their order same. Suppose I have a polynomial zx, and that is x cube plus x square plus 5x. Then I have another one px, which is just x plus 4. And if I want to add them, then what I do? You write zx plus px. So you better write this zx first, that is x cube plus x square plus 5x, and the constant term is missing, so I prefer writing 0 there. And there for px, this is zx, and now what is px? The x cube term is missing, so you write here 0x cube plus x square is also missing, 0x square plus x plus 4. Now you just underline them and add. So it is 6x plus x cube, sorry, this is x square. So this is x square and this is x cube. This is the sum. Same way you can find the difference also. And now if you want to multiply, then you have to multiply them using, like suppose if you want to find out the product of px into zx, you write the zx smaller one first. So I write x plus 4 times x cube plus x square plus 5x. Then this is the product of a binomial. Binomial means the expressions which contains only two terms called binomial. The binomial, and this is trinomial. And what is this is called? Tetranomial, and all these are called polynomials. So binomial is the expression which consists of only two terms, x and 4. So x plus 4 together is a binomial. So when you multiply a binomial with trinomial, you better make this one as the two monomials. So first you multiply this x with this whole expression. So this is x cube plus x square plus 5x plus 4 times x cube plus x square plus 5x. That is x to the power 4 plus x cube plus 5x square plus, I am getting 4x cube, so I will prefer writing here 4x cube plus 4x square and plus 20x. Just add them. This is x to the power 4 plus 5x cube plus 9x square plus 20x. Is this okay? Now I want to find out the division. What happens, how we can find the quotient? Like if one polynomial is divided by another polynomial, how will you find the quotient? So for that, again I need to clear my screen. Now we are trying to divide a polynomial. Suppose I have a polynomial 5x cube plus 2x square plus 7x and plus 10. And I try to divide this polynomial by a polynomial of degree 1, x plus 2. So I am trying to find out what will be the value of px over gx. So we can divide by the normal division. You just write like this. This is your divisor. So write like this: 5x cube plus 2x square plus 7x plus 10, and then write here x plus 2. Now you have to multiply this by a term so that you can get 5x cube. So you know this is x, so I'll write here 5x square. So now 5x square multiplied with this 5x square multiplied with this x will give you 5x cube, and 5x square multiplied with 2 will give you 10x square. Now subtract just like the usual division. These two cancel, and the 2x square minus 10x square will give you minus 8x square. Let's get one more term down. This is 7x. Now I have to get minus 8x square. So I'll write here minus 8x. Minus 8x into x is minus 8x square, and this is minus 16. So plus here, cancel. 16 plus 7, now this is 23x plus 10. So here we have to get 23. So write 23. 23 into x is 23 plus 23 into 2 is 46. And now you cancel. So you get your answer is minus 3x. So what you are getting? This is your divisor. What is this? Divisor. What is this? Sorry. This is dividend. This is dividend. This is divisor. This one is called as quotient. And this one is called remainder. And you might have studied in standard 4 or 5 that this is called the division algorithm, which says that dividend is always the product of the quotients and multiplied the product of the quotients and the divisor and plus remainder. So dividend equals divisor into quotient plus, let me clear this one, plus remainder. This is called as division algorithm. Numerically and algebraically both you find this is always true. Like if you multiplied x plus 2 with 5x square minus 8x plus 23 and add 36 to this, I will get 5x cube plus 2x square plus 7x plus 10. Now there is another shortcut way of solving this equation, and that is called a synthetic division. So that is shortcut, synthetic division. How you do that? You simply write the coefficients of the dividend, so which are 5x cube. So just write 5. Then it should be in the proper sequence, like if any term is missing then you have to add 0 for that. So this is 2x square, so you write 2 here. Constant term is 7 and then you write 10. So these 4 terms in the standard forms, if there are 4 terms, you can be sure this is a constant term, this is the linear term, this is the quadratic term, this is the cubic term as whole. Just you can, in your mind you can make it is 5x cube plus 2x square plus 7x plus 10. And now when you try and divide it by x plus 2, so now set x plus 2 is 0, then you get x is minus 2. Like if you say in your mind x plus 2 is 0, then x equal to minus 2. So this is minus 2, I write here. Then you just draw a line and put this one directly here. Don't do anything, just drag it down. So 5 is here. Now multiply this minus 2 with 5 and put the result here. So minus 2 into 5 is 10. So 10 comes here. Now add these two. This is 12. Now again multiply this minus 2 with this. So this is minus 24. Add these two. Then how much you are getting? Minus 24 plus 7. That is minus 17. Minus 17. And then you multiply this minus 17 with this minus 2. So minus 2 and minus 17, this will become 34. And then you add these two, you are getting 44, which is not equal to 0. Means this is not divisible. So x plus 2, so minus 10. And oh, I made a mistake here. Minus 2 and the 5 should be minus 10. Now minus 10 plus 2 should be minus 8. Minus 8 into minus 2 is 16. And 16 plus 7 is 23. And this 23 into minus 2 will be minus 46. And then if I add, I'll get minus 36. Yes, so now you check this one, minus 36 and minus 36. Now suppose if the minus 36 is 0, it means, so again I would like to explain you this because I messed up a little. So first what I have written, that I have written the terms 5, 2, 7, 5. These are the coefficients of this expressions, 5, 2, 7, 10. 5, 2, 7, 10. Then this is the divisor where x plus 2 I am trying to divide. So just find a numerical value which may make this x plus 2 0. So minus 2 plus 2 will 0. So any number which can make this expression vanish, that is minus 2. So that I have written here. If you find difficult to guess, then you can set this one directly to 0. So you can get x plus 2 0, therefore x is minus 2. And then first one, don't do anything, just drag it down. Whatever it is, just leave it there below. So this is minus 4. Now multiply this minus 2 with this minus 5 and that result, so will be coming here. So multiply this with this and the result comes here. Now add these two. So 2 plus minus 10 is minus 8. Now again multiply minus 2 with minus 8, this is 16. And then add to 16 plus 7, 23. Then again you multiply minus 2 is 23. This gives you minus 46. And then you add again these two is minus 36. It means this 5 minus 8, 23. Check it out here. 5 minus 8 plus 23. It means these three terms will form your quotient. So what it is? 5x square minus 8x plus 23. And the last term, which is the constant term, this one will be a remainder. So this is minus 36. Suppose if this is 0, means there is no such remainder, means you can say this expression px is completely divisible by zx, and that is called that perfect division, and you have no remainder. This is all in this video. In the next video we'll discuss about some more examples of the synthetic division, and then we'll discuss the factor and the remainder theorem. Thank you very much. Just subscribe to our channel and keep practicing with us.